Hello everyone, it's the MathPhysWiz here. In this session, I'm going to talk to you about graph theory. This is our first video on graph theory, but we may continue with more videos if you are interested. So what is a graph? A graph is basically a way or a method to represent basically any type of networks there is. For example, you can see a network here, which is a friendship network between different peoples. We have represented peoples as nodes here. So you can see that, for example, this is Tony, this is Thor, and this is Steve. And if a line exists between two people, we know that those two people are friends. We call these types of lines edges in terms of graph theory. So in a graph, we have nodes and we have edges. And we're representing this specific friendship network with some sort of simple graph. So basically, what we can infer from this graph is that Tony and Thor are friends, Tony and Steve are friends, Thor and Steve are friends, Thor is also friends with Jane, and Steve is friends with Bucky. But we can observe that, for example, Tony is not friends with Bucky. And the reason for this is that there is no edge existing between Tony and Bucky. So this graph is basically and very simply telling us that Tony and Bucky are not friends. And we can also see that, for example, Jane and Tony are not friends because if they were, we would have seen an edge existing between them. And so on. For example, Jane and Steve are not friends, Thor and Bucky are not friends. So we can get a lot of information from observing a graph. But if we want to get more technical, for each graph, we have first a set of nodes. In this specific example, our set of nodes contains different names, different Avengers names, which includes Tony, Steve, Bucky, Thor, and Jane. We also have another set, which is basically the set of edges which exist in our graph. In the graph you saw before, we can observe different edges that exist, but if we want to write them down, we can write them this way. As a pair of node names. For example, when we've written Tony and Steve here, it's because there is an edge between the node Tony and the node Steve. Or we've written Tony and Thor here because there is an edge between Tony and Thor. And basically, by having these two sets, the set of nodes and the set of edges, we're basically able to rebuild the graph that we were trying to describe by drawing. So instead of drawing, we can just provide people with these two very important sets. Now that I've mentioned the basics of a graph, we move on to solve an example together. So suppose that we know our graph has n nodes. So this is given in this problem. We know that the graph has n nodes. And when we know that a graph has n nodes, instead of assigning a name to each of the nodes like we did here, Tony, Jane, Thor, Steve, and Bucky, we can assign numbers. So our nodes are now named from 1 to n. So we have node 1, node 2, node 3, and so on until node n, depending on what n is. So my first question from you is that how many edges are possible to exist in this graph. Let me tell you an example. Suppose that we have a graph with two nodes. So we only have node 1 and we only have node 2. So how many edges are possible to exist in this graph? In this specific graph, when n equals 2, the answer is 1 because we can only have an edge between these two nodes, 1 and 2. So this edge, either it exists or it doesn't. So we have only one possible edge. Or, for example, if we had 3 nodes, 1, 2, and 3, there could have been an edge between nodes 1 and 2, or between nodes 2 and 3, or between nodes 1 and 3. Is there any edge that I'm missing? No, I've covered all of the edges that could possibly exist in this graph. So in this case, the answer equals 3. But what about the general case? We cannot always count the number of possible edges as n grows large. What's the general answer? Could you please think about it for a minute? And then I'll give you an answer. So if you're watching the video, please pause here and try to solve this problem yourself. And then play it to see the answer. Alright, so in this case, this is how we get the answer. So we have n possible nodes. But what forms an edge? As I described earlier, an edge is basically a pair of nodes. So what we need to do in order to solve our example question is to find the number of pair of nodes. And if you remember your math, we have a very basic concept for this. The number of possible pairs from n choices is simply n choose 2. And if you do not remember this, we can have a video on this later. So just please comment if you want to see a video on the concept of choosing and how we reach these symbols and the formula for that. Okay, so if you want to know the mathematical expression for n choose 2, it's basically n times n minus 1 divided by 2. And this is how many pairs of nodes we can choose. And you can check it for the two example cases which I've written down. So if we have n equals 2, the answer gives us 2 choose 2, which is basically 1, and that's the answer we got earlier. And if n is equal to 3, then the answer is 3 choose 2, which is equal to 3, and this also matches our answer. Now we move on to the next question I want to ask you. For a graph with n nodes, how many possibilities are there? How many possible graphs can we have? So let me give you another example here. Suppose n equals 2 and we have node 1 and node 2. So how many possible graphs can we have? Firstly, this itself is a possible graph because this is a graph with no edges existing in the graph. And another possibility is that we have node 1 and node 2, and these two are connected. So these are the only possible graphs we can make with 2 nodes. So the answer in this case is 2. What if n equals 3? Let's count that. So we have node 1 node 2, and node 3. So firstly, this is a graph itself. Node 1 can be connected to node 2. Node 1 can only be connected to node 3. We can have node 1 alone and nodes 2 and 3 connected together. We can have two edges coming out from node 1 to nodes 2 and 3. We can have two edges coming out from node 2 to nodes 3 and 1. We can have two edges coming out from node 3 to nodes 1 and 2. And lastly, we can have all of the possible edges. So the answer for n equals 3 is actually 8 possible graphs, as you can see here. But what's the general answer? Please pause here and try to find the general answer yourself. All right, let's check if you've gotten the answer correctly. So, based on the previous question, if we have n nodes, this gives us n choose 2 possible edges. Each of these edges either exists or do not exist. Therefore, there are two choices for each edge. And because we have n choose 2 edges, then the number of possible graphs is actually 2 to the power of n choose 2, which equals 2 to the power of n times n minus 1 divided by 2. And you can also check that this formula actually matches the answers we got for the cases where we have 2 edges and 3 edges. So, thank you very much for watching this video. I hope that it has helped you in a way in graph theory. We can have other parts for graph theory and any part of math and physics which you have problems in. Please just comment and subscribe to the channel to receive more contents like this.